Welcome to Disney's Dolphin Research Laboratory. Today we will attempt to figure out which of our dolphins are vocalizing. We have Professor Ricketts here from Carnegie Mellon University. He has agreed to help us find a solution to our problem.
So, what is your current solution?
Currently, we are using a technique known as localization. Here's a picture. We are trying to separate the dolphins into different tanks, hoping that we will be able to identify which one is vocalizing. We also have a hydrophone in each tank to monitor their vocalizations.
And how has that been working out?
Unfortunately, not too well. Because dolphins can mimic each other's voices and have a broad frequency range with varying speech patterns, physical separation doesn't help. We are currently 35% accurate.
That's not too good.
Well, that is where you and your students come in. We know how awesome you guys are, and we were hoping that you could help us with our dilemma.
I think we can figure something out. Let me go ask my team of innovators and see what they think. Okay, they have come up with a solution and I think it will really work.
You didn't call anyone.
Yes, I did.
You didn't even leave.
Yes, I did.
Fine. So what did they say?
Okay. They suggested that we redefine the problem. They now want to determine where the dolphins are in the tank at all times. From there, we would be able to figure out which dolphin is vocalizing.
Your students must be really smart. Redefining the problem seems like a good idea, but I don't completely follow.
Would you believe me if I told you that if we had the origin of the vocalization and the location of the dolphin, we could determine which dolphin was vocalizing?
No, I wouldn't believe you.
Well, if the origin of the vocalization and the location of the dolphin are the same, then we can conclude that the dolphin in question was responsible for the vocalization. Our only assumption is that two dolphins can never be in the exact same location at the same time.
Simple enough, but how are we supposed to determine the origin of the vocalization? What about the dolphin's location? And can this be done in real time? What kind of equipment do we need?
Whoa, one question at a time. First, let's talk about the setup of the tank. The tank will be lined with an array of hydrophones. The kind you have should work, but we will need a lot more. The more hydrophones in place, the more accurate our trilateration will be and the less we will have to worry about reflections.
How do you know that using more hydrophones would produce more accurate results?
By using TRES, of course. By wanting to improve measurement accuracy without damaging reliability, TRES tells us that we should parallelize more operations. This means that we should be using more hydrophones.
That makes sense. TRES rocks. Now, what is this trilateration you were talking about earlier?
Trilateration is the process of determining absolute locations by measurement of distances. Look at this. By figuring out how much time it takes the sound to get to the hydrophone, we can determine how far away the sound is. All we need is 4 hydrophones. Using 2 hydrophones gives us a circle of possible locations. Using 3 gives us 2 possible locations. Therefore, if we introduce a 4th hydrophone, a unique point is found, which is the location where the vocalization originated.
Oh, I think that makes sense. Isn't that how GPS works?
Yes, exactly. In the case of GPS, 3 satellites are used, resulting in 2 possible points. One point is in outer space, so it can be ignored. The other point is your location on Earth.
Okay. That sounds like a lot of processing. Is that even possible?
It is definitely possible, but we won't be able to determine who is vocalizing in real time.
That's fine. We go over all the data later anyway. What other equipment will you need?
We will be attaching 2 omnidirectional speakers to each dolphin. One speaker will produce a signal below dolphin's hearing range, and one will create a signal above. We use extreme frequencies so we don't interfere with the dolphins communicating. Each signal will be unique so we will be able to identify a dolphin just from its signal. We will trilaterate these unique signals, allowing us to track the movement of every dolphin.
Why are you using 2 extreme frequencies?
We plan on taking the average of 2 trilaterations, which will result in a more accurate location. Two different wavelengths allow us to overcome problems with reflections and diffractions, as short and long wavelengths have unique characteristics that we will take advantage of.
That sounds complicated. Do you perhaps have some sort of visual that can help explain this?
No. I'm sorry.
What about that visual behind you? Wait, where did everyone go?
They are probably at Fatheads. Do you mean this visual?
I love dancing. We now know where the dolphin is, and we are able to track it. So how do we determine the origin of the vocalization?
Good question.
Well,
finding the origin of the vocalization will work exactly the same. The dolphin acts as the speaker and its speech is trilaterated, which gives us the origin of the vocalization.
So now that we know the location of the dolphin and the origin of the vocalization, it follows that if the two are the same location, then that dolphin was responsible for vocalizing.
That is correct.
This sounds like an awesome idea.
I know.
So what's the catch?
Would you believe me if I told you there wasn't one?
No.
Darn. The biggest problem is from sound reflections in the tank. This can be mitigated or even eliminated by increasing the number of hydrophones in the tank. Placing hydrophones on the bottom of the tank would be best. However, we will still have problems locating sounds when the dolphin vocalizes straight up, where there are no hydrophones to receive the signal. The trilateration should still work, in theory, but it will be less accurate.
I really think this solution is going to work. We will finally be able to tell when Calvin, Rainier, Khyber, and Malabar are vocalizing. The rest of my team will be so happy. Thank you, Professor Ricketts, and thank you, Chen, Daniel, Manu, Alex, and Matt. On behalf of Disney Research, you guys are amazing.
Peace out.